Hi guys, it's Mrs. Moss here, and for the next couple of videos we're going to be discussing the moon. So those were the words that were uttered by the astronaut who first landed on the moon. Let's review a little bit about the moon's orbit. We talked about planetary motions and how orbits are eccentric. Well, the moon's orbit is slightly eccentric as well, and the moon's distance from the Earth changes as it revolves. So this change in distance will cause the apparent size of the moon to appear smaller or larger depending on where it is in the revolution. And this happens in a cyclic manner. Now, the moon's apparent diameter appears at its largest when it's at the perigee and it's closest to the Earth. And the moon appears smallest at the apogee, which is when it's farthest away from the Earth. So again, we mentioned the apparent diameters and how the change of size appears to be depending on where it is in its revolution around the Earth. And when the orbits of the moon and Earth are elliptical, it gives it that different appearance of the size. Now this will happen in a cyclic manner, making the relationship cyclic. So let's look at some of these facts about the moon. It's a natural satellite, meaning it was not man-made. And it revolves around the Earth about every 27 days, and it rotates once in 27 days. So it's a very slow rate of rotation. The Apollo astronauts that we saw in our first slide, they landed on the moon in 1969. And as you notice, you can see many craters on the surface of the moon. Here's a closer up look. You can see the craters that have been made from meteors and other celestial objects crashing into it. So let's talk about that a little bit more in detail. Why are those craters still there? Well, there is no atmosphere on the moon, so there's no erosion going on or no weather that will help cause those craters to disappear. So whatever crashes into the moon and creates a crater, that crater will stay there. And it's also geologically inactive, meaning there is no volcanoes occurring to wipe away any surface features, and there's also no plate tectonics occurring as we have on the Earth, so the craters are going to remain. There is no magnetic field on the moon. It's made of relatively small iron core, and as we mentioned before, it has a slow period of rotation. It takes 27 days just to rotate once. The Earth is 1/4 the size of the moon. The moon is 1/4 the size of the Earth, and it's 1/6 the surface gravity. So there's less gravity on the moon. Here's a picture of the first 3 men to walk on the moon. We have Neil Armstrong, Michael Collins, and Edwin Aldrin, or Buzz Aldrin. So we're going to continue on and talk about the moon phases. And if you notice this animation, you see a highly advanced footage of the moon changing phases. So let's talk about why this occurs. Well, there's a few things we need to know before we talk about that. The moon does not produce its own light. It's illuminated because it reflects light from the sun. Half of the moon is always illuminated, facing the sun. And that also means that half of the moon is also dark. The portion of the half that is visible of the Earth changes throughout the month. The lunar phases occur because the moon revolves around the Earth. And this is a cyclic event. The moon completes its cycle of phases once every month. So if we take a look at the way the moon's phases appear to an observer on Earth, it happens for a very specific reason. Based on where we are located on Earth and how we are looking up at the Earth, we always see one side of the moon. And the portion that's illuminated is going to depend upon where that moon is in its revolution around the Earth. So if you look at these V's that were just placed on this diagram, that is what the observer will see based on where they're standing. So if we look, I'll show you in the next slide. If you're standing here and you're looking straight on at this side of the moon, you notice it's a full moon. this is what you see. You see the whole moon fully lit up. However, if you're standing from this angle, slightly as the moon revolved a little bit more around the Earth, you'll notice only a portion of the moon is lit up, and it's a majority of it is lit up. I'm going to put the cursor over here where this green is blocking. This is only the visible light that's being shown from an observer standing right here. And so this moon phase is what the observer sees. It is called a waning gibbous. So this is what the observer will see from standing in this location on Earth. Let's look at another one. If we're standing here and we are looking up at the moon, we'll only see this portion, half of it, lit up. So this is considered the third quarter because the left hand is lit up. One more, we look at this as a waning crescent. And if you look at from this location, you only see a very small sliver of the moon from where you're standing. And because it's the left side that's lit up, it's called the waning crescent. So you are going to be responsible for understanding the moon phases. Okay, so let's look at this diagram again as a whole. Whenever you see a diagram like this, you first identify the new moon. And that new moon will always be closest to where the rays of the sun are coming from. So in our instance here are the rays of the sun, and so this must be the new moon. Now, using the technique that we showed you in the previous diagram, this observer looking up at the moon wouldn't really see a moon. It would be dark. So we consider that the new moon. From here, the moon will revolve counterclockwise. So we go up to phase number 2, and this is considered the waxing crescent. Now from the new moon to the full moon, the light of the moon will gradually increase. So it gets to its maximum amount of light at the full moon stage. So we consider the first few moon phases to be waxing or maxing out the light. If the light is growing gradually, and it's going to start growing from the right side. So when you look up and you see the right side lit up, you'll know that it's in the waxing portion. It's going from the new moon to the full moon. And this second phase is considered a crescent. The person only sees a very small sliver. Then in the third phase, but it's considered the first quarter, it's half of the moon is lit up. It is the right half of the moon. And the right half of the moon continues to get brighter. And this gibbous phase, it actually looks like an egg. It's almost full, but it's not quite full. And then the fifth phase would be considered the full moon phase. And that's when we see the moon as a complete circle, a full moon. Now, from the full moon to the new moon, it starts to get less and less light. So we consider the light to be draining or waning. So these next 3 phases are considered waning, and they match the same phases with the waxing. So the next phase after the full moon is considered a gibbous again because it looks like an egg. Now the difference with the waxing gibbous and a waning gibbous is that now the left side of the moon will be lit up. So you will start to see the darker portion of the moon being covered from the right. Here we have the third quarter. This is also going to be a half moon, but this time the left side is going to be lit up. And a crescent, just a sliver of the moon is going to be remaining, and that's going to be the left side. And then we're back to the new moon phase. So we go from dark to bright, and then we go from bright back to dark. And this period of time takes 2 weeks to go from new moon to full moon. It takes another 2 weeks to go from full moon back to new moon. So it takes roughly 4 weeks, or we say 27 days to 29 days for the moon to revolve around the Earth. So let's talk again about this moon rotation and versus the revolution. If you notice, the moon's rotation and the revolution are the same. And because the gravitational force of the Earth, the rotational period of the moon is equivalent to the revolution period. And so we only see the same side of the moon each night. We never see the back side of the moon. It's always the same side of the moon, and that's due to the fact that it rotates and revolves at the same rate. We're going to stop here, and we're going to continue talking about the moon in relation to the tides and the eclipses and the special things that can occur because of the moon in our next video. So I hope you have a great day. I hope you got down the notes. I would pause and I would stop the video and go back and listen again this time now that you've taken all your notes, and just hear me and listen again and make sure you understand. Have a great day.